Hi guys! Today we are going to present about SBA and ARCHAD. Firstly, this is our group member Muhammad Faris bin Muhammad NASIR, me Ahmad Hasif bin NORZLI, IRFAN MUSTAQIM Ahmad ZAINI dan NABIELLAH NAELIS bin SHAHRIR.
For the SBA and ARCHAD, SBA and ARCHAD is a pair of control charts with a subgroup size of 2 or more in call and X-bar and range, or the other name of the R is R range chart. If a process is stable and predictable, can be determined using the standard chart for a variable data, X-bar chart and also R chart. Basically, the R chart display how the range of the subgroup changes over time, and X-bar chart display how the mean or average changes over time. It also utilized to keep track of the impact of theory for process improvement. Typically, the way or how to use X-bar and R chart is when you have taken data oftenly, so XR chart should be used. The size of your subgroups determine how often you put point on the chart. Typically, for this kind of chart is subgroup size 4 to 5, where the n is less than 10. If you are rationally subgroup the data and are interested in detecting changes in subgroup difference over time, you should use XR charts. This means that the method of subgroups are formed should have some of the logical basis. Where X-bar charts representing variation between these, where R chart represents variations within these. In a short term, variance in the process is measured by the R chart. To reduce the amount of variation within a subgroup should be formed. However, this causes the X charts to do the work in detecting process changes. Next, the objective for the control charts is mainly known for the quality improvement, for decision regarding product certification, and also for current decision on the production process and to determine the process capability. However, some other objective for the control chart is for current decision on recently produced items. We can see that SBA and R chart can be have two elements that consisting of rational subgroup and also subgroup size, which is the first one. Rational subgroup is when only difference variable explained for the variation within a group. That group is known as a rational subgroup. The control limits are determined using the within subgroup variation. In a long-term stability is assessed using the variation between subgroup. The second one is subgroup size, whereas the control limit are moved to sensitive to small variation in the process average as the subgroup size increase due to the being closer to the central value. The cost of the inspection per subgroup increase as the subgroup size increases. In other words, we have two schemes selecting subgroup sample, which is the first one to choose sample from a product that was produced at or as close to the instant of possible, which is most commonly used since it provides a particular time reference for determining assignable causes. The second one is where I choose a product that is representative of all products produced over a period of time. So this is where it provides better overall result and will provide a more accurate picture of the quality. So there's three major advantages by using this kind of chart, which is the first one is simple and easy to read for understanding, which is it's a very efficient to use in industrial lines, and also it enables control chart based on principle used by the system. And lastly, the major advantages that we can see using this kind of chart is it can help to differentiate average variation for standard deviation variation.
However, there are a few disadvantages in constructing SBA and R chart. The first disadvantage is there must be a separate chart for each characteristic. The second disadvantage, it is always necessary to use two values per subgroup in order to estimate the standard deviation for the range regardless of the sample size. And third one, for sample sizes greater than 9, these methods can accurately indicate process variability. So the next one, I will explain about the step in constructing SBA and R chart. So the first one is gathering the data. 1. Select the size of the subgroup. Typical subgroup sizes range from 4 to 5. It is critical to take into consideration the idea of rational subgrouping. The objective is to reduce variation within a subgroup as much as possible. 2. Choose how frequently the data will be collected. Data collection should occur in the order that is generated. Third, choose how many subgroups K or G will be collected before control limits are determined. After 10 subgroups, you can begin with initial control limits. 4. For each subgroup, record the individual, independent sample results. And the last one, for each subgroup, calculate the subgroup average and each group calculate the subgroup range. The formula for X bar is shown at the below of the slide. As we can see, the total of X is divided to N, which is the N is the number of the subgroup. And the formula of R is equal to X min minus to X minimum. So the second one is step to calculate the overall average and control limit. So the first one, calculate the average range, which is R bar. The formula of R bar is equal to summation of R divided to K, which is the sample size. And the, number 2, calculate the overall process average, which is X double bar. The formula is shown that the summation of X is divided to K, which is K is the sample size. Third one, calculate the control limits for the X chart. The upper control limit is given by upper control limit X. The lower control limit is given by lower control limit X. As you can see, for the formula of upper control limit X, the X double bar is plus to multiplication of A2 and R bar. For the lower control limit X, the X double bar is minus to A2 multiplied to R bar. And the fourth, calculate the control limits for the R chart. The upper control limit is given by upper control limit R. The lower control limit is given by lower control limit R. For the upper control limit R, the formula is D4 multiplied to R bar, while lower control limit R is equal to D3 multiplied to R bar. This is the formula to show that the A2 value, D3 and D4 that we got from the table, which is we refer to the subgroup size. As example, for subgroup size number 7, the A2 value is 0.419, for the D3 is 0.076, and the D4 is 1.924. So, as we got the formula of A2, as we got the value of A2, D3, and D4, we can get the value of upper control limit R and lower control limit R, and also upper control limit X and lower control limit X. The next one is step in constructing X bar and R chart. To plot the data, the first one, we need to select the scales for the X and Y axis for both the X and R charts. Number 2, plot R bar on the range chart as a solid line and label. So the third one is plot X on the X chart as a solid line and label. 4, plot the control limits on the R chart as dash line and label. Number 5, which is the last one, is plot the subgroup average on the X chart and connect consecutive point with a straight line. And also plot the subgroup range on the R chart and connect consecutive points with a straight line. So this is the example of the result as we plot the graph. So as we can see, the upper graph is the X bar chart. As you can see, on the y-axis they are sample mean, and the x-axis they are sample. For the X bar chart, we can see the upper control limit value is 6.294 and the lower control limit is 4.586. As example, if there are a certain point that exceeded the upper control limit or lower control limit, the value is unselected or determinate. For the below graph, we can see the example for R chart. As you can see, the y-axis is for sample range and the x-axis is for sample. For the upper control limit, there are 3.129 and lower control limit are 0.
Okay, so now I'm gonna present to you guys on example for X bar and R chart. So here I attach with some small quote which says, what studies say the number one best way to start an exercise habit is to give yourself a reward that you can genuinely enjoy. So let's proceed. Okay, so for the first slide, it shows a set of data where, as you can see, there's only 3 subgroups for each samples. The subgroup can only be less than 10 subgroups. So from here, from this table, we can see we have like 12 samples of them. So the objective of this slide is to show you how to calculate the X double bar and R bar. So as you can see, to get the X double bar, you have to get the total of X bar, which means from each subgroup, you have to take all the data and get the average of it, and then take all the average of the average and average it. And then we have same goes to the range, get the average data and get the average of it. Okay, so for the next slide, I'm going to show you on how to calculate the UCL and LCL for X bar chart and R chart. So the value for A2, D3 and D4, this is important because we need to use it inside the formula to get UCL and LCL. So where to find this number? We can get this number from the table given. Okay, and then for UCLX, the formula is X double bar plus A2 multiply with R bar. So it's going to be 0.283. That's like the example of it. For LCL, for X bar chart, the formula is X double bar minus A2 times by R bar. So that is the formula. And for R chart, UCLR, we need to take the value of D4, which also gets from the table, and multiple with R bar value. R bar going to be constant for both UCL and LCL. And then we're going to get 0.069. This is the example. And also same goes to LCL for R bar. R chart, sorry. D3, value of D3, which is 0 times by R bar. So the number going to be 0. Okay, next. This is the example of R bar based on the sample, based on the example given lah. And then we have all the values here. As you can see, the plotted points are the average value of the subgroups. And then we plot the line, plot the data, and then we connect the lines. And then, like just now, we calculate the UCL and LCL. We just like put a straight line across the graph. And then same goes to LCL, just put a straight line. What is center? What is the pink color line? If you're wondering, center, get from just now, we get the average from X double bar. Okay. Next. And for R chart, same goes like just now. We plot the lines, we plot the dots, and then we see whether it is in line or out of line. Yes, whether the data is in control or out of control. As you can see, there is only for this data, for this set of data, there's only one point that is out of control, which is above the upper control limit. Like back to previous slide, like for this, you can see there is only two points whereby it is out of control, which is one on the 14th and on the 16th. On the 14th above the UCL, and on the 16th below the LCL.
So we go next. All the value and the range and S bar should be lying between upper control limit and lower control limit. If some value above upper control limit and lower control line, means that some value are off control. To make the value in control, so we have to eliminate this control and calculate the revised control limit. So we go to revised central line. Firstly, we need to calculate again, same with the step before. So we need to find the S new and R new using this formula. So, but to find upper control limit and lower control limit, there are a little bit different for formula that have sigma naught equal to R naught divided by D2. D2 can find from the table. So when we plotting the graph, there are no value that at upper control limit and below control limit. So the conclusion, there are many use for R chart and S bar graph. Use them to evaluate the stability of the system before you start making improvement to it. This is the main S bar and R chart function. Next, determine whether certifying the data is necessary after evaluating the stability between shift, amount of employees, between various equipment, and amount of variety of material that we can find completely different results. Next, S bar and R chart can also be used to evaluate the effect of the process improvement that we will analyze the process current condition and contrast it with its previous state. Lastly, R chart and S bar can be used to standardize. So, this is our reference, and thank you. Assalamualaikum.